Hey everybody, in this video we are dealing with polynomials. Alright, shout out to the students. And now, in my videos, depending on what's going on or whatnot, I give shout outs. Now, I was trying to do it over the intercom, but I didn't get permission to do that. And I want to shout these students out for being so awesome, so skilled, and so perfect. Now, class 1A and 2B, they were the dopest kids I have ever dealt with, because not only did they kept they calm while I was pushing them through that scenario, they gave the best responses and they gave the best participation. Like in 2B, everybody participated in that classroom. Not a single student didn't participate. And I was still impressed with 2B. 1A, now 1A in particular, I would say they had the best participation over 2B, but 2B had the best response and was the most calm out of the bunch. But they was neck and neck. But I was still impressed with both 1A and 2B, so pat yourselves on the back for good job. If you could do what you did within the first week, 1A, 2B, I got a feeling that you're going to do well in this class. 1A, 2B. 1B, I was impressed with your effort. All you guys gave me some good effort. I didn't have no issues with nobody in 1B. Now, I'm going to, address, well, not address, but to shout out the other students who made a very strong impression. And you made a strong impression by giving the best participation. You gave some good questioning. You gave some good thinking. Your responses to your teammates was awesome when we did the teamwork. That is the reason why your name is talked about here. Miss Smith, she surprised me, but I was thoroughly impressed. Caston, cool as a breeze, but still handling his. Toussaint, quiet but very effective with his work. Jason, very vocal but gets the work done, and really serious about making things happen for his future. Derek, respects his teacher and just make things happen. Brady, very strong, very respectful, an eloquent speaker. Quentin, responses are always on point, and always. His reasoning is very fantastic. I like the way Quentin thinks. A. Howard, he's very detail oriented, and that's what I like about him, and that's going to help out in the long run. Collins made sure I knew who she was day one. Washington brothers, I know you guys don't like to be grouped together, but you guys was evenly matched in terms of what I did in my class. One of you was the voice of reason of the class. One of you was very more calm and tamed in terms of the scenario I put you guys through. Hayes, whoever said that first impressions is everything, sadly got this wrong, because my first impression of Hayes was not nothing too nice, but he turned it around and demonstrated that skill. I was sold. Very sold. So good job to that person. Winfield, best response, well, smooth response. Ask those good questions. Dempsey, would you say the same thing as Mr. Winfield? Eli, awesome work. English, always eager to answer the question. Even give his other classmate a chance to answer before he decides to do so. Mrs. Now, you told me to call you Mrs., so I'm going to call you Mrs. Good work. Also, best teamwork. Bolden. Well tamed, but I want to focus on Mrs. because her and her group that she works in was spot on out of the 2A class. That's the one thing that I can always remember out of 2A is her and that group that participated well, Miss Smith, and some of the other few students who I mentioned in this who are in 2A. So good job, everybody. I was very impressed. Keep handling your business. The biggest shout outs I could give, all right? All right, guys. Like I was telling you today, your student objective, multiply, divide polynomials. But in order for this to for this to happen, we got to go through certain things such as distributive property, simplifying expressions, exponent properties, factoring, reviewing quadratic, square root, cube, and cube root functions. That's how we're going to make it happen today. What is mathematics? Remember on your syllabus, I told you that this is going to be a key component of my classroom. So you're going to see this a lot, and you will see this on every test I throw at you. What is mathematics? The technique to explain, understand, and manage reality specifically by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. Ooh, Mr. Howard, that was a lot. So what does that mean? And how does this work? Well, you know how you kids always ask questions, and believe it or not, when I was your age, I asked the same thing. What is math? Because throughout your schooling, you never knew what math was, so you just made it like an inference of it. Oh, it's about numbers and shapes, and we're mathematical definitions. That's how you would identify what mathematics is from the experience you dealt with. But this definition is the precise definition of mathematics. Because as I tell you as a teacher, I tell you, everybody uses math. What's the truth? But the problem is when I say that to you, you're like, I don't get it. So that's why the definition come into play. For example, as a teacher, any teacher, we use mathematics particularly to count. For example, when we do attendance, we gotta count. Classifying you guys, that's the counselor and the admin to classify what kind of student you are, such as a freshman, sophomore, senior, and all that. Ordering based on your grades. And believe it or not, that is how a teacher, from my experience, use the precise definition of mathematics. Will everybody use all parts of this definition? No, but you're going to at least use one word of this definition of mathematics when you work. As a student, you use this definition of mathematics to count. We all count, so let's just get that out the way. So therefore, you are using mathematics. You are measuring things, measure the time you got left in the classroom, Classifying, you look at them grades and you classify which teacher's a good teacher and which one bad. Inference, you make inferences in everything. Like if I was coming across hard, mean, and gave y'all a lot of work, you would see me as a bad teacher. That's you making an inference. You make an inference based on what you're seeing. All right? Keep this definition in mind and all the examples I just mentioned because those are things that I will be testing you on and asking you more on about throughout the year. Do not forget, mistakes allow thinking to happen spells out math. Mistakes allow thinking to happen. That means that if you work on a math program, if you get it wrong, mistakes are appreciated, respected, and appreciated. It doesn't mean, oh, you're going to get F. As long as you're working the stuff out, giving the effort, that's fine. On your test, I'm looking for the growth of it. Looking for how much you grew from when I first taught it till we come to that test. And that's what I mean to be accurate. Accurate means you're showing the level of growth. But I'm looking for the accuracy part only on the test. But if you fail a test, does not mean you failed a class. So please understand that mistakes allow things to happen. If you make the mistakes, I got enough time to help you think through it so we could correct it, so when you go to take the test, you'll be perfect. All right. A lot is going on in this, huh? Well, the reason why I got this going on because I want you to know that math comes from all over the world. This means that it's not just some particular group of people creating mathematics and all this, all that. All the stuff that you know about mathematics came from Africa, the US, Europe, Asia, South America. It comes from all over. Although throughout the world we speak different languages or whatnot, math is universal. All right? So if we solve an equation, I may say the words differently, but it'll be all the same. All right? And the reason why I brought this up because you have a project coming up to understand what I mean by math originate from all over the world. Where does number come from? Check your Google Classroom. That project is there and adhere to all the policies there. So again, go to Google Classroom, it's there. And you're going to know that the numbers we use came from a certain place. And that was brought over throughout the world. And that's how we use our numbers. So that's going to be due on whatever date that I post in Google Classroom. Please adhere to the to all policies such as academic integrity and the deadline policies of assignments. Also the attendance. So guys, please don't copy and paste. Don't cheat from each other. You could talk to each other about it because that's what you're going to do anyway. But I don't want to see the same project from another student because both of you guys are going to get zeros. All right, let's proceed. All right, let's distribute and let's simplify. So guys, expand, simplify, factor. So let's look at this first problem here. You've seen something like this before, and don't forget, if you haven't had a teacher, please do not feel bad because I'm going to teach it to you as if it's brand new, all right? So guys, for those who had a teacher, a problem like this that's on the left-hand side is pretty easy to deal with. You got to do two things, and these things are very essential to what we're dealing with today, expanding and simplifying functions. All right, so when we are expanding or /simplifying, we got to use a property of distributive property when it comes to that 3. Why? Because all our operations, PEMDAS, tells us the first thing that we have to do is work on our parentheses. But can you do anything in this parentheses? No. Why? They got nothing alike. You can't do nothing with unlike terms. You know, if I would have that 2x in the parentheses, then I could work it. But it also means that I get to work outside the parentheses too. So anytime you have a number next to the parentheses, you distribute that, which is still part of the parentheses part of order of operations. All right. And one more thing, because you have a 3 outside the parentheses, that also means multiplication. So you multiply. So 3 times 4 is 12x. 3 times -2, -6. And you got this 8 right here. So now you could combine your terms. So you got 8, positive 8, minus 6. When you work in your integers, you will subtract those two. So 8 minus 6. If I have 8, but if I owe you $6, how much money do I get back? $2. 2 plus 12x. Usually in the math class, this is done. But usually in the math class, we like to write our number with the variable first, then the constant, which is just the number without the variable. So either way of those are fine. Anytime you see me do this, that means that that's my final answer. All right, so we just expanded and we simplified it. All right, so let's work on this right hand side. So when I mean factor, what am I talking about if I say factor? What I'm telling you to do is to take that 16 and the 28 and to determine which numbers, which factor, biggest factor, your GCF, which you saw in your ACT practice that we did last week, tells you which factor is the largest in common. I'm sorry, let me re-ask that question. So with 16 and 28, what is the biggest number or factor that 16 and 28 have in common? So let's find out. So 1 times 16 gives you 16, but none of them are, well, 1 is in common with 28 because 1 times 28. All right. 2 times 8 gives you 16, but 4 times 4 gives you 16 as well. I didn't write 4 twice because I'll be repeating myself, and when it comes to this, you don't need to repeat yourself. All right. So for 28, 2 and 14, 4 and 7. So with that being said, what is the biggest numbers you see? So for the 16, I got 1, 2, 4, 8, and 16. When I multiply these numbers, 1 times 16 is 16, 2 times 8 is 16, 4 times 4 is 16. Then 28, 1 times 28 is 28, 2 times 14 is 28, 4 times 7 is 28. The biggest number is 4. Now, because that's the only thing that they have in common, notice this problem don't have another Q anywhere, so you can't do nothing with Q. So guess what? Put your 4 out in the outside, get your parentheses. So now we got to go back and figure out what 4 times what gives you 16 and 4 times what gives you 28. 4 times 4 is 16, and 4 times 7 is 28. Now, you're going to include all these stuff that was in the original, like the minus and the q. So it was 4q minus 7. And you could check your work. Well, you've done the factoring part. This is complete. That's the factoring you just did. But to check your work, or to expand or simplify, just do what you did on the left-hand side. So again, the parentheses, there's nothing in common. So you got to multiply. So 4 times 4q, 16q. 4 times negative 7 is negative 28. And that's how I find the answer to that. So, bam. Again, those are important skills that you must know to survive Algebra 2. All right, so look. Now, we got to go deal with exponents. So here is all the exponent rules. In Google Classroom, I did provide the cheat sheet for you to look at, which is going to help you. Please note that in every lesson, well, I will try my best to always provide you with cheat sheets or reference sheets. I'm also going to make the time in my classroom to produce anchor charts so you could look at those. All right. So I'm going to run through these right quick, exponent properties, and move on. So guys, when your bases are the same and you got multiplication going on, you add the exponents together. Again, this is the multiplying powers with the same base. When you multiply, the bases are the same, you add them. What about dividing powers? When you are dividing, you subtract them. So a good way to remember is this. So when you think about multiplying with dealing with exponents, well, you flip the multiplication symbol around, it looks like addition. When you are dividing, you just get rid of the dots in between, you get subtraction. So that's how I remember it. All right. Finding a power rule. So when you got an exponent outside the parentheses, you multiply them. When it's a negative number, you write it as a fraction. Anything to a power of 0 is 1. All right. All right. I'm going to do one of these examples for you, and you're going to try the 3 on your own. I'm going to do this guy right here. So for this guy, the reason I'm only doing this because later throughout the year, you're going to have to learn how to do it too. So anything with a square root could be rewritten as x to the half power. So anytime you see that, you just a square root is rewritten as x to the half power. So before we could get to all this, let's go ahead and take care of this. The square root of 9x. Well, we know the square root of 9 in itself is just 3. X. And you could do it like this if you choose. Leave your parentheses out like that. Well, this is the way that you want to do it. Again, for this, I will explain much more as we get closer to that particular topic. Now, these other 3, use your law of exponents cheat sheet that I just previously mentioned and try to work this out. And then after that, I have a Kahoot for you in Google Classroom for you to practice those laws of exponents. All right, now multiply and divide polynomials. That's what we have to do. So we distribute and we simplify, so we know how to work a little bit on this. We actually got to deal with polynomials, so this is what we must focus on. All right, yeah, what is a polynomial? What do we know about polynomials going back through Algebra 1? Well, I have a definition for you. And to sum all this up, a polynomial is pretty much a function that has exponents and or more than one term. Like these examples here. This one right here is a polynomial because you have multiple terms. You have 3 different terms, and also you have the exponents too. So let me read through the definitions to help you guys out. The degree of a polynomial is the highest power of x in x expression. Constant non-zero polynomials, linear polynomials, quadratics, cubics, quartics are polynomials of degree, pay attention, of 0, 1, 2, 3, 4, and respectively. The function f of x equals 0 is also a polynomial, but we call it undefined. So here, let's look at the first one. That's a polynomial because going from the definition, the cube 3 is the highest exponent from the function. For the function. All right. And this is of course cube, and we know what cubit looks like. Here, below it, this is also a polynomial, but why? Looking back at the definition, it tells us that the degree of 0, 1, 2, 3, 4. So let me ask you this. Do I have a degree of over here? Remember, when I say in degree, I mean exponent. So like this x to the power of 3, that's an exponent. That's called a degree. All right. These functions on the right hand side, this is not a function, a polynomial function. Although this has an exponent of 3 in front, being the biggest, but because it have what is this called? Square root. This is not a this is not a polynomial. Here, in the bottom, this is also not polynomial because you have a rational number there. So this is also a no. You have a square root and a rational number. So a polynomial cannot have a rational and a square root. And of course we know rational means to divide. So cannot have those two things. Please adhere to that, because that is something that I will be kind of questioning you on. Polynomial functions. Now, let's go through these. The linear functions, we ain't going to talk too much about because you know what they are, what it looks like. You know that the domain of this is all real numbers, and the range is also all real numbers. So what is this function called right here in the green? The cube root. What about its domain? All real numbers. Posing or being cryptic about is going to help you understand about polynomial functions. All right, here's a challenge question. 5 is a polynomial. Explain in at least 3 sentences of why 5 is a polynomial. So, let me give you a little hint. Not really much of a hint because you're going to kind of push yourself to think. Go back to the early parts of this video. There's something that we did before that's going to kind of help you. So come through, go back to the beginning, or if you're clever, go to Google Classroom and go look at a particular cheat sheet. That should help you. All right, y'all saw this before. I gave this to you guys as the first homework, and I wanted to discuss it because it is essential for us to understand the error that was made so we can move on and make it work for what we got to do for the heart of this lesson. Error analysis. What's wrong here? Many of you guys gave me answers like 14a or 10a squared. You just gave me a random number. What I was asking you guys to do is to identify the error. So I may, on a test, I may put some of you guys' working answers and make it into a test question in regard to this. So let's look at it. What was wrong here? A few of you guys caught on and you realize that the negative sign was distributive wrong. Because here, when you distribute, the 10a part was right. Negative 10a was right. But when you multiply a negative times a negative 2a5, that no longer becomes a negative, it becomes a positive. And it's the same thing when I do the distributive property again, because I got two negatives that become a positive 14a to the power of 4. That was the mistakes being made. Now with that being said, let's go ahead and clean this up and go start combining like terms. So find your like terms. So I got a 12a5. Do I have another a5? I do. I have a 2a5. And when I mean 5, I mean to the 5th power. So 12a to the power of 5 plus 2a to the 5th power. Power of 5, 5th power means the same. So that's going to be 14a to the power of 5 or 5th power. Okay, then I got a negative 6a by itself. So negative 6a minus 10a, because I'm subtracting two negatives. Negative 6a minus 10a, that's going to be a negative 16a. And it's so easy to get that wrong because you would think, oh, I'm working with two negative, it becomes a positive. The only time that happens is when you multiply by two negatives. All right. Do I have anything to the power of 3? I got negative 10a cubed, which is the same way as saying power of 3. So I don't have no other pair with that, so that's just going to be 10a cubed alright, and then do I have a 14a to the power of 4th? Of course I do, but I don't have a pair, so I can't do nothing with that, so it's just 14a to the power of 4. So, can you combine these terms together to get a single answer? No, you can't combine this. Why can you not combine? What's going on here? Why can't I not combine? I highlighted some stuff. I'll need for you to figure that one out. And that's something I may quiz you on. Alright, multiplying and dividing. Now, we're going to use a law of exponents to make things happen. But let's do a fast review. So if I have 4n times n, so where's my base at? The 4 that 8? No, that's wrong. Your base in this case is going to be the variable. Your variable is always your basis. So when you multiply, because you have the same basis, which is n, you're pretty much adding. So that's going to be n 1 plus 1, and that's n squared. So what about if I have 36 n squared divided by 6n? Simplify. 36 divided by 6. That's just 6. But remember, when you divide, you got to subtract the n's. Well, the exponents of the n's. And the n's are, again, are your bases. So 2 minus 1, that's 6n. Alright, that's a quick review. And that's how I did this. These are similar examples to a problem like this one and a problem like this. Alright. I want you guys to try these two problems on your own, and we compare notes. And again, do your best on it. If you are struggling with it, come talk to somebody. If you get it wrong, that's cool too. Talk to somebody still. Alright. Guys, I'm going to work the problem to the left to kind of help you out. But the problem to the right, I'm going to let you try that one on your own. Alright. So here, you got some distributing going on. Show you how to do it. So here, you want to take this first term, multiply it by all those terms. So that's what we're going to do. I'm drawing my arrows to let me know how to multiply those terms first. And then this 2 right here, I'm going to multiply that last. Alright. So because I am multiplying, I could make, and my exponents are, my bases are s, I can make things happen. So 3 times negative 2 is what? 6x. And then I got s to the power 1. S squared, that's x cubed. I'm setting s as in snake, not x in xylophone. Alright. Well, let me change my color so you guys could understand what I'm doing first. So I'm doing everything that I did in the black. So that's -6, because 3 times -2, x to the power of 3. All right. So 3s times s, that's just 3s squared plus 3s times 2. That's just 6s. Okay, I did everything in the black. Now I'm doing everything in the red. So in the red, 2 times -2s squared is -4x squared. Okay, 2 times s is 2s. And 2 times 2 is just 4. Alright, so this is what I want you guys to do. So now, combine your terms, which you're going to do, and I'm going to see what you come up with, and that's that. Alright, homework. As I told you before, mainly Kahoots. And please be aware, the Kahoot in itself, they may be long-winded because of the questions, but because of the material we're covering, you need a lot of that practice, because I promise you, although it's like, oh, it's too much, the better the practice, you're going to be all right. And remember, it's just you going to Kahoot and just doing it. You could do it over your phone. And even if you do not have Google Classroom, come see me. I will write down the Kahoot code so you could go to the website and do the information there. Alright, be mindful of the following. Make sure you turn in the homework on time. Please adhere if you are absent. Make sure that you get the excuse that you get 3 days prior to losing points. And remember, after the 3rd day, it's no grade. Alright, y'all.